Greeting. Today's lesson is both a review of everything we gone over and an introduction into using the SenseHat piece of Trinket. This will allow us to use our code to interact with a simulated Raspberry Pi. So we'll start off at first reviewing the for loop, and then we'll move on to using these loops and different pieces inside of the SenseHat module. So the first thing we're going to do in the for loop is create a variable, and you don't have to do it this way, but this allows us to change it. We're going to create a variable, and this will be how far a loop goes up to. So in this case, let's just call the variable num, and we're going to set it to 10. Now we actually create our for loop. So the for loop has all of the pieces we need inside of it. So with that, we do for, and then I in range, and now here is where you can actually type a number, but in this case we're going to use a variable, so it's going to go up to whatever our variable is. So in this case, let's go for I in range num. Let's not forget our colon at the end. And now, if you remember, when we only add one number into range, it starts at 0. So I will start at 0 and go up to, but not including num, which in this case is 10. So let's first then print the actual incrementer. So the incrementer in this case is I. It is the number that's going up every single time this loop. So print I. And then we want to add an if statement to this. We want to say if the incrementer is greater than 5, the number is greater than 5. The incrementer is greater than 5. So if, and remember the incrementer is I, so I is greater than 5. Again, just like the for statement, the if statement ends with a colon. Enter, it automatically indented for us. Now we write our print statement. So print, and again, this is going to be a string, so therefore we use quotes. The number is greater than 5. All right, so now we have this all set up. Num is 10. For I in range num, which is 10, it's going to print. So this will print 1 through 10. However, whenever the number is greater than 5, it will also print the number is greater than 5. And we can see this when we run it. 0, 1, 2, 3, 4, 5, 6 is greater than 5. 7 is greater than 5. 8 is greater than 5. 9 is greater than 5. And like all programming, the order matters, so it starts at 0 because I starts at 0, and we printed it before it increments. So therefore you can see that it goes from 0 to 9, which is a total of 10 loops. Alright, so that is most of what we went over so far. We have an integer, we set it to a variable num, we looped through that, we printed that integer, we used a conditional statement, the if statement, and then we printed a string. So we went over a lot of what we went over so far. Now the next part is going to be adding that to a Raspberry Pi. And you can see as I scroll down, a little too fast, that we have this Raspberry Pi off to the right. Now this is the Astro Pi. This is what Raspberry Pi actually got sent into space. So this is a $10,000 case for a $35 computer. So it can go into space. If you click the little button down here, it will change it into what we are going to use, the Raspberry Pi with the SenseHat on top of it. Which basically it is a little LED matrix with a controller, and yes, you can spin it as well. And you can use the arrow keys to move it, and then it has temperature, humidity, barometer, all that good fun stuff. So the first thing we need to do, and we'll go over this in a later section, is add these 3 pieces. Again, I'll explain what they do, why they're there later, but basically what you need to know is, in order to get this to work, you need to import extra information. The Python comes with a bunch of commands, but if you want more commands, you need to actually get them to come in. So in this case, we get the SenseHat commands, and we're going to use the time command so we can slow the program down. The next big piece you need to really understand is we take that SenseHat, all those commands, and we put them into this variable s. And what you need to know about that is when we use it, since we used an s, it's always going to be an s. So see this s.lowlight equals true. Therefore, we have this s as all of the SenseHat commands, they're held in this s is one way to look at this. So in this case, s.lowlight equals true is setting the lowlight command to true. So the light on this is going to be a lowlight. All right. So now I'm going to uncomment some of the code so we can kind of see what's going on. So first thing we have is we're going to set num to 6. And we'll see what that means in a little bit. Very similar to what we just did. The next is we're going to set a color. Now again, this is just a variable. Pink is a variable, aptly named because this color combo is pink. Now notice it has parentheses around it. So in this case, it needs parentheses. It needs to look exactly like this. We'll go over what the 255, 105, 180 means. But for now, realize that when you write it like this, this is actually the color pink, and we'll see that down below. So the next piece I'm going to uncomment is our for statement, which we just did. So for I in range, num, so 6. So this is going to loop 6 times, but again, it starts at 0, and it's going to go up to 6, so it means 0 to 5. So the last piece is the command that we really want to see. This command right here is going to modify and actually make something change on this device. So instead of seeing lines of code and input and typing and all that fun stuff, we're actually going to see this device change. So again, notice this, s dot show message. All right, that is the command to show message, very similar to print. But again, it is a SenseHat command, so it needs this s dot in front of it. Now, we are going to display a number, but it needs to be a string. The whole point of this command, show a message, is that it's a string. So I am converting I into a string. If I was to actually display another message, I would have to type it with the quotes because it's a string. But for now, I'm just displaying the number, so I'm displaying the green. Now, this was created by the Brits, so notice that it has a U in this, text color. And again, we set it to pink. I could have just actually added the code here, but this allows me to change the color later and kind of show you what I'm doing. So I'm going to say pink. So when I run this, it should loop through this message 6 times, which the message is just the iterator. So when I run this, you'll see on the left hand or the right hand side, 0, 1, 2, 3, and it's going to go all the way up to 5, just like we said, because that's what the loop does. It loops 5 times, displaying the message. So if we had a longer message, say I did the hello world, it would display hello world 6 times. Again, nothing fancy yet, but we just made something show up over here, right? So there's now something that shows up over here. You also notice it has toggles up here for temperature, pressure, and humidity. We'll be using those in a future project, so do realize it has that. All right, now I'm going to show you 2 links. These are going to be really important links for you. The first one is actually the SenseHat page. It has examples of where you can find SenseHat information. Then we have the color picker. Now, I mentioned about the color picker before. We have these numbers. What do they mean? Well, it's an RGB concept. So RGB. So how red it is, how green it is, and how blue it is. So if it's all zeros, then it has no color in it. If it has all 255, which is the highest number it goes to, then it has all of the colors in it. So we can see that. We can run 255, 255, run it. Oops. And of course I add an extra 1. So we run this, 255, 255, and that's white. So 255, 255, 255 is white. Pink, sorry, pink no longer makes sense right now, But again, I'm just showing you how these work. 255250. And if I wanted red, 25500 gives me red. But what if you want other colors? So if you click on this link, it will take you to this HTML color picker. All you are interested in, as I just showed you red, are this whole thing. So you need the parentheses. Don't forget the parentheses. You need the parentheses. But you can click anywhere. So if I want this color of blue, this is, again, all of the numbers that I need to make it happen. If I want this color, again, that's what I need to happen. And if you click on here, you can get the different shades of these as well. So you can grab any color you want. Now, that doesn't mean it's going to look exactly the same on this emulator over here, but you can just click on the color picker, copy the code, and then paste it over into this. And now, when I run it, it's going to do its best to try to look like that. And you can see it really looks nothing like it. It's slightly pink. It's doing the best it can. But at least you know the code for when you actually get to the real Raspberry Pi and it has real LEDs. So that is the SenseHat. But there is a whole page also to the SenseHat, and this is the page. So it's going to start off on this page. It's going to have different trinkets as it be, and you can see it's just rotating through them. But the key here is the code. So notice they still have the from SenseHat import time. They have s equals SenseHat. They have it. So this is actually where I got my code, and that's why I'm showing you this, because a lot of the time you get the code from here. Now, later on, we are going to go ahead and get the temperature. So if you look at these different trinkets, one of them says sensor, which says select temperature, pressure, humidity. This might be a good spot to find our code. So we go here. Notice this time, and this is why I showed you this before. This is important. It is now sense equals SenseHat. All right, so that is a huge thing to think about when you're looking at other people's code is they don't need to call the variable the same thing. So we have over here s equals SenseHat. So every time we call a message, s equals s.show message, s.low_light. But over here it's sense. So when we see here, in this case they're just showing a letter, and I actually have to stop this and run this, and you'll see it show up over here. So as I move, and this is temperature, as I move this, you can see that the lines change. That's what this program does. The hotter it is, the more red you see, and so on and so forth. And again, if you click on this, it'll take you back to the Raspberry Pi version of it. So somewhere in here, it has to get the temperature. Somewhere in this code, it's getting the temperature. So, and amazingly, it's not that far down. You really would think somewhere it would have the word temperature, right? Somewhere in here, it has the word temperature. So, scroll down to line 39, sense.temp equals temp. So, if you look at this code right here, this is where it's actually getting the temperature. This piece of code goes out to this little sensor, and again, this is all simulation, so it goes out to this temperature, and it gets the temperature, and then it changes. Now, this is where they do the conversion, so they can turn into the dot value, but key is right here, this is where they get it. And they set it to a variable, so you don't need to use this every single time. So you have this temp as a variable. But this line of code is where they get the temperature. So you can use that temperature over and over again. But notice, it says sense.temperature. If you were to copy this and paste it into our program, and then try to print it into this spot, remember, we got to change it to a string. So if we do this sense dot, it's already given us the thing. Sense is not defined. Watch out for these errors. These warnings are there to help you. So it says sense dot temperature. It's not there, right? It's because we have it labeled as S. Again, let's look at that. S dot equals SenseHat. We go over here and we scroll to the top. They have sense equals SenseHat. So we need to make sure we understand that. So in order to fix this, the easiest way is just make this S. S dot. S dot. Now when we run this, the 52 degrees point, it's going to give us point something. But there, you can see it printed 52 degrees. That is the temperature. So this is where you can get some extra code if you need examples, you want to see it. It's a great spot but you need to make sure that you're finding the right information. Humidity, pressure, but realizing it's still using sense. Again, these are important concepts to understand when you're bouncing around in different code sets, or you might get different pieces of information. All right, so we're going to keep going down. And this last piece, I want you to work in teams to figure out. So you're going to work on this practice, and you're going to try to figure out how to do it. I already have all the imports there for you. So you need to go ahead and just write the code. You just have to write the code. Now, I just showed you how to get the temperature. So you need to make a message that says, while the temperature is less than 100, show the message, it's not too bad in here. And here is the kicker. This print I lied is not inside the while statement. Because as soon as they exit the while statement, that means the temperature is over 100, and it's now is bad in here, 100 degrees. And this is Celsius, so remember, water boils at 100 degrees Celsius. So it's pretty bloody hot when it's 100 degrees Celsius. There's one more gotcha you need to watch out for this. If you get the temperature and you run your while loop, remember, the code goes in the right order. So it's going to get the variable, and then it's going to run that loop. Remember, we talked about with while statements, you need to give it a way to actually exit the while statement. So think about that for a little bit. You need to possibly update the temperature, and then again, outside of the while statement. So remember, you indent to go inside of the for whiles. It's the same concept. In order to be inside of this, and if to be outside of it, you unindent. So in order to have that last piece, you need to unindent. All right, so you have your resources. You have your SenseHat page. You can kind of look at the code for how to get the temperature. You can use the color picker. If you scroll up, this show message code is right here. So again, you have all the information you need. You're going to need to find a color. You're going to need to write the SenseHat. All the code is on this page. It's now up to you to solve this and make it so it gets the temperature, and then it goes into a while statement. So while the temperature, which you just created a variable, so while that variable is less than 100, show the message it's not bad in here. And again, you need some way for it to recognize that the temperature is above 100. And you can pull this over, but if you don't tell it, it doesn't by itself just figure that out. You need to find a way to update it. And then after when you finally pull it over 100, that should exit the while statement. And then once that's exited, you go ahead and print I lied. So that's the last piece. Now notice the show message is going to show up here. When you print, it's going to pop up the shell command right below this. So you'll see below it the shell command, and that's where the print's going to go. So we're going to do a lot of this where we use the shell command, which this will show up in the shell command, and stuff will show up on the Raspberry Pi. So this is for testing, and this is to actually get the program, the Raspberry Pi, to do something. So there's a lot of time where you'll print variables. You don't want to make the variables show up, but you'll print them for testing, and then you can comment them out with that hashtag. Just throw a little hashtag in here. Print something. All right. So with that, again, work with the person next to you and solve this equation before we move on.